In this lecture, we will discuss balancing redox reaction by ion electron method. Basically, there are two methods to balance any redox reaction. First method we have, that is oxidation number method. Another method we have, that is called ion electron method. Now this method, ion electron method, is more important, and generally we use ion electron method to balance the redox reaction. So in this chapter we will be discussing only ion electron method. Now oxidation number method is basically based on change in oxidation number must be equal. So what is the idea? So oxidation number method is based on total gain in oxidation number is same as total loss in oxidation number. So this is the oxidation number method. Now ion electron method is based on total number of electron lost is equals to total number of electron gained. So this is ion electron method is based on so let us say we have an example. So let us say we want to balance this equation. So we have been given, so this is a half reaction only in ionic form. So we have ions. So this is the ionic equation. And we want to balance this ionic equation. So what is the first task to balance equations? First task is decide which atom is oxidized and which atom is reduced. So we have to decide oxidized and reduced atom. So let us say in this case, first we have to write oxidation numbers. For chromium in this case, I have oxidation number is +3 and chlorine has the oxidation number of 0. Now this chlorine has the oxidation number of -1. And what is the oxidation number of chromium here? So we can write this is basically 2x. So let us say chromium has the oxidation number of x. So 2x, and one oxygen has the oxidation number of -2. So 7 will have -14, and this is equals to -2. So from here I can write x is equals to 6. So chromium here has the oxidation number of +6. So if you see the chromium here, it is oxidation number is +6, but here oxidation number is +3. So that is reduction. So this process, that is reduction in oxidation number, that is loss in oxidation number. So this is basically reduction. Now let us say this process, chlorine. So chlorine here has the oxidation number of -1, and there is a +0, that is increase in oxidation number, and increase in oxidation number is called oxidation. So what is my first task? My first task is we have to decide which atom is reduced and which atom is oxidized. So in this case, chlorine atom is oxidized but chromium atom is reduced. And upon this basis we can make two half reactions. So let us say we can make two half reaction. First half reaction we can make this one and this one. So what is the first task? First task is decide which atom is gets oxidized and which atom is gets reduced. Second task will be write two separate equations, reduction equation and oxidation equation. So we have to write two separate half reactions. Now in this case this is a reduction half and this is a oxidation half. So we can write two separate equations, Cr2O7 2 minus to Cr3 plus. This is a reduction half, and Cl minus to Cl2, this is the oxidation half. Now we will separately balance these two half reactions. So what is the idea next? So we have to balance two half reactions separately. So there are two things that is important in balancing. In any reaction we have to balance charge as well as atom. And charge balance is basically coming from conservation of charge, and balancing of atom, this is coming from mass conservation. That is, if I have any reaction, total mass remains conserved, and if I have any reaction, total charge remains conserved. That is, balancing of atom, it is coming from mass conservation or material balance. And balancing of charge, this is coming from charge conservation. So let us say for this reaction I have Cl minus and this goes to Cl2. So let us first balance atom. So if I see this side we have one chlorine atom, this side we have two chlorine atom. So we have to multiply this side by 2. Now chlorine atom is balanced. So you see chlorine atom is balanced. Now charge is still not balanced. So we have to balance charge in the next case. 2Cl minus, this gives you Cl2. If you see this side we have total 2 negative charge. One chlorine ion has a 1 minus charge. So 2 ion will have 2 minus charge. So this side we have 2 minus charge. This side we have 0 charge. So to balance this charge we have to add electron. So we can add 2 electron this side. Now this equation is balanced. So this half reaction, that is 2Cl minus, give to Cl2 plus 2E. This is the first half reaction. So first balance half oxidation half reaction. So we can say 2Cl minus Cl2 plus 2E. This is balanced oxidation half. Now let us go to the reduction half. So we have in this case Cr2O7 2 minus goes to Cr3 plus. We have to again follow the same steps, that is we have to balance the atoms and we have to balance the charge. So let us first balance chromium atom. So we have Cr2O7 2 minus Cr3 plus. Now we have this side 2 chromium atom, this side we have 1 chromium atom, so we have to multiply by 2. So now chromium atom is balanced. But still oxygen is not balanced. This side we have no oxygen, but this side we have 7 oxygen. Now another important point, whenever we have to balance oxygen, we have to add H2O. And wherever we want to balance hydrogen, we have to add H+. So balancing oxygen can be done by adding H2O, and balancing hydrogen can be done by adding H+. So let us say we have 2Cr3 plus. Now let us say balance oxygen. So we have 7 oxygen this side. So we have to add H2O. And now this is 7 and now oxygen is balanced. To balance oxygen we have to add H2O. So we have added 7 H2O. Now oxygen is balanced. This side we have 7 oxygen. This side we have also 7 oxygen. But now see H plus hydrogen. This side we have 14 hydrogen. This side we have no hydrogen. So we have to balance hydrogen. So to balance hydrogen, we have to add 14H plus this side. Now let us check whether each of the atom is balanced or not. Chromium is balanced, so we have 2 chromium atom, 2 chromium atom. We have 7 oxygen atom, 7 oxygen atom. 14 hydrogen atom, we have 14 hydrogen atom. So now I can say chromium, hydrogen, oxygen, all are balanced. Now next is balanced charge. So we have balanced atom, we have balanced basically oxygen, hydrogen, that is also atom, and then we have to balance charge, that is material balance we have done. So this is a part of material balance. Let us balance charge. So we have 14H plus Cr2O7 2 minus, and this gives you 2Cr3 plus 7H2O. Now let us see the charges. This side we have 14H plus and 2 minus, that is 12H plus. So this side we have 12H plus, that is 12 plus charge, and this side we have only 6 plus charge. So what we can do, this side if we add 6 electron, then I will have only 6 plus charge, because 6 electron will neutralize 6 proton. So we will have 12 minus 6, that is effectively we will have 6 positive charge. So if we add 6 electron this side, we have 6 positive charge this side, and this side also we have 6 positive charge. So now charge is also balanced. So we have two balanced equation. Let us try to see here once again. We have total charge 14H plus 2 minus. So if I subtract 2 from 14, we have 12H plus, that is we have 12 plus charge. This side we have 6 plus charge. We have to have both sides 6 plus charge, because charge has to be equal, and this is possible only if I add 6 electron, so that we will have 12 minus 6, 6 positive charge. This side also we will have 6 positive charge. So we have balanced reduction half, we have balanced oxidation half. Now what can we do? To get the overall reaction, we have to add these two half reactions. So we can get the overall reaction by adding these two half reactions. So let us say the first half we have, that is oxidation half. Oxidation half we have here, that is a reduction half first, and let us say oxidation half is this one, 2Cl minus Cl2 plus 2E. So we have here 2Cl minus, and this gives you Cl2 plus 2 electrons. So this is your oxidation half. Whenever you have loss of electron, that is called oxidation. So in this case we have loss of electron. So loss of electron is called oxidation, and gain of electron is called reduction. If you see the previous slide, we have the reduction half. So reduction half is this one, Cr2O7 2 minus, and this gives you 2Cr3 plus 7H2O plus 14H plus this side. So let us say we can write this reduction half, that is Cr2O7 2 minus, this gives you 2Cr3 plus 7H2O, and this side we have 14H plus 6 electron. Now to get the overall reaction, what we have to do, we have to cancel the electron. That is this side we have 2 electron, and this reduction half we have 6 electron. Since in a reaction there is no accumulation of electron, this means the total electron lost is equals to total electron gained. So what is the principle? Principle is electron lost is equals to electron gained. So we have to cancel the electron, that is there is no electron that will be left at the end of reaction. And this can be achieved if I multiply this equation by 3. So I will have 6 electron and then we can add. So let us write here. So we have 2Cl minus. If I multiply this equation by 3, so we will have 6Cl minus, and this gives you 3Cl2 plus 6 electron. Now we will have 6 electron plus Cr2O7 2 minus plus 14H plus 2Cr3 plus 7H2O. Now if we add these two equations, we will have 6 electron, that is cancelled. We have Cr2O7 2 minus plus 14H plus 6Cl minus 3Cl2 to Cr3 plus 7H2O. So this is the balanced equation. Now we see in this case we have H plus, so we can also call this reaction is balanced in acidic medium. We know in acidic medium H plus is always available. So this reaction is balanced in acidic medium. Now we know how to balance the oxidation reaction by ion electron method. So what we have to do first, we have to locate what are the atom that gets oxidized and what are the atom that gets reduced. And once I know what are the atom that gets oxidized and reduced, we can make two separate reactions, that is two oxidation half and reduction half reaction. And once I know oxidation half and reduction half, what we have to do, we have to balance the oxidation half and we have to balance the reduction half. In balancing the reaction, we have to consider material balance, that is a balance of atom, and charge balance, that is the balance of electrons, that is the total charge left side is equals to right side. In writing the overall reaction, we have to keep in mind that there is no accumulation of electron in the solution, that is solution remains neutral at the end of this reaction, or there is no loss of electron from the solution, that is solution does not provide any electron to this reaction. This means total electron lost is equals to total electron gain. And if I use this idea, we can cancel electron from oxidation half and reduction half. To cancel, we can always multiply one reaction by 2, 3 coefficients, and then we can add by cancelling the electron, and then we'll get the overall equation. If I have H plus in overall reaction, this is called equation balance in acidic medium. If I have OH minus in the overall reaction, this is called equation balanced in basic medium. Now we will balance this equation by ion electron method. The first step to balance is we have to find oxidation number of atoms, and then we have to look what are the atom that is changing their oxidation number. Now in this case manganese has oxidation number of +2 because charge on manganese is +2, so X is equals to +2, so manganese has oxidation number of +2. What is the oxidation number of chlorine? Let us say chlorine has X and oxygen will have -2, so there are 3 oxygen, so X minus 6 and total charge is -1. So from here we have X is equals to +5. So in this case chlorine has the oxidation number of +5. What is the oxidation number of manganese here? So let us say X, and one oxygen will have -2, so 2 oxygen will have -4, and this is equals to 0 because there is no charge. So basically manganese have oxidation number of +4. Now what is the oxidation number of chlorine? Let us say X, and oxygen is -2, so there are 2 oxygen, so minus 4, and this is equals to 0, so x is equals to 4, and this is plus 4. So now let us say manganese, there is an increase in oxidation number, so 2 goes to 4, so this is oxidation. Increase in oxidation number is oxidation. Now let us say chlorine, this goes plus 5 to plus 4, so this is basically a reduction. Now we have to write two half reactions separately, so let us write first oxidation half, so we can write Mn2 plus, and this goes to MnO2. Now let us try to balance this one. So first we have to balance atom. This side we have one manganese, this side also I have one manganese, so manganese is balanced. Now this side we have two oxygen, so this side we have to add 2 H2O. Now this side we have 4 hydrogen extra, so we can add 4 hydrogen, and we have to add H plus. Now atom is balanced. Then we have to look for charge. This side we have 2 plus charge, this side I have 4 plus charge. This means we have extra plus charge. If we add 2 electron this side, now charge is balanced. So now atom is balanced and charge is also balanced. So we have balanced oxidation half, and oxidation half is basically Mn2 plus 2H2O, and this gives you MnO2 4H plus 2 electron. Now let us discuss reduction half. This reaction, that is ClO3 minus goes to ClO2, is reduction. So we have ClO3 minus, this goes to ClO2. So this is reduction half. You see this side we have 3 oxygen, this side 2 oxygen, so we have to add H2O. Now oxygen is balanced, we have to look for hydrogen. This side we have 2 hydrogen, so we have to add 2H plus. Now let us say charge. What is the total charge this side? We have 1 plus charge, and this side we have 0 charge. This means we have to add 1 electron this side, so that we can have 0 charge this side also. So this is reduction half. You see, this is a gain of electron, and gain of electron is always reduction. So let us write reduction and oxidation half both together. This is Mn2 plus goes to MnO2. So this is your 4H plus will go basically this side. And this side we will have 2 electron. Now if I multiply this equation by 2 and add, so let us say multiply this equation by 2, and this will give you ClO2. Now let us add these two equations. 2H2 also gets cancelled, so we will have Mn2 plus, and 4H plus also gets cancelled, so we will have simply MnO2 plus 2ClO2. So this is the balanced equation.